So this is what we call parallel. Okay. So I think that's one is clear. Then we move to, okay, this is an example from your textbooks. So this circuit shows that the number of node, branch, and loops. Okay. So as you can see here, for this circuit, we have 3 nodes, A, B, and also C. So we have 3 nodes, and then the branches. So we have 1 branch, second, third, fourth, and fifth. So we have 5 branch. Okay, and 3 nodes. And about the loop is actually we have how many loops? This one is actually 1, 2, 3. Okay, we have 3. So for this circuit we have 3 loops. Okay, very simple and straightforward. Okay, so example, so determine how many branches, nodes, and identify which element are in series and which element are in parallel. So first we go for the branch and nodes. So for the branch, so we have 1, 2, 3 branch, and 4. Okay, 4 branch. And what about the node? The node we have 1, 2,
3 dot.
yeah, 3. This is not node, okay? This one is not node because there is no element here. So this is still considered as a one branch, one nodes, okay? So we have only 3 nodes. Okay? Okay, and then identify which element are in series. Which element are in series? Series is actually the element should share
in one loop.
1 nodes. Okay.
Resistors.
Which resistor? In series right now. This one, okay? These 2 elements are series because it share 1 node. Meaning that the current flow through this element are the same. Okay, so if the current here is 5 amps, so the same current will flow here 5 amps. So this is series. Okay. I think for the series, only this element are in series. Next, we go for the parallel. Which element are in parallel?
The 6 and 2.
Yeah,
And
6 and
that,
2 because
yeah.
it shares this one. 2 nodes. Okay. So this branch and this one. So this overall, this one is actually sharing the same 2 nodes, meaning that it is parallel. So meaning that the voltage across 6 ohm is actually the same voltage across the current source. So just want to note that for the current source, you have also voltage, okay? Voltage across the current source. Okay? And also, you can say that these 2 elements are also parallel with 6 and 2 ampere. This one. Okay? So if I just redraw back, okay, if I rearrange this one, as you can see right now, so this one is 6 ohm, this one 2 amps. So the voltage, okay, across this is same voltage across 5 ohm and 10 volt. Okay, meaning that the voltage across 6 ohm is the same voltage across 2 ampere, and this one is the same voltage across 10 plus V across 5 ohm. Okay. So this one you can say that are in parallel. 10 volt connected with 5 ohm are in parallel with 6 ohm and 2 amperes because it shares 2 nodes. Okay. So I think this one determine how many branches. I think this one is very straightforward. Which element are in series and are in parallel? So as you can see, this one are parallel. Okay. This one also parallel. Okay, meaning that the voltage across 4 ohm is also 10 volt. Okay, this is important. You need to know the characteristic of the parallel and series. Okay, so the since 10 volt and 4 ohms are parallel, so meaning that the voltage across 4 ohm is also 10 volt. What about the voltage across 1 ohm and 2 ohm? Is it 10 volt? Is 1 ohm and 2 ohm are parallel with 10 volt? Any answer? Is it 1 ohm and 2 ohm are in parallel with 10 ohm?
No, because there is a
No,
series
doctor.
with 5 ohm.
Yes, yes.
Yes, with 5 ohm.
Yeah.
5
Huh?
ohm. Due to 5 ohm, there is something.
Yes,
No.
yes. So meaning that 1 ohm and 2 ohm are not parallel with 10 volt, okay? Because we have this. We have this one. Because in between them, we have 5 ohm. So this one is not parallel with this one. Okay? Okay, I think that is the basic of a series and parallel connections. So that is the most important part. So for the series, the current is actually the same. And for the parallel, the voltage across the element is the same. So right now, we want to go for the Kirchhoff laws. Okay. So actually, the basic Ohms law that we have already used or we have learned, which is V is equal to IR, which is the Ohms law, is not sufficient to be used to analyze the circuits. Okay. There's this one. This Ohms law standalone cannot. It's not what you call sufficient. Okay, so what we need to do is actually we need to apply another what you call methods to analyze or to solve the circuit analysis. So we will use what you call the Kirchhoff law. Kirchhoff law. So for this Kirchhoff law, we have two category. Okay, we have currents law and the voltage law. So what is the Kirchhoff current law? So this is the first law of the Kirchhoff. So it states that the algebraic sum of the current entering a node or a closed boundary is 0. So what it means that if you have a node and you have a lot of current, okay, circuit, okay, for example, this one is I1, this one is I2, this one is I3, and this one is I4. Okay, the summation of all the current that going into and out from one single node must equal to 0. So for this course, so every current that enters the node, you should put positive sign, and the current out from the node is negative sign. So meaning that from here, we can say that I1 is positive because it's entering the nodes, I plus I2 plus I3, and the only current that go out from the node is I4. So negative I4, and this one must equal to 0. So if I rewrite again this equation, it is logically that I4 is actually the summation of all I1, I2, and I3. Okay, because I1, I2, I3 must equal to I4. But this one is actually comes from this one. And this ones come from this basic definition of current Kirchhoff law. Okay, so for this course, always maintain that for the current that enter the node, you must put positive sign, and for the current that go out from the node, you must put negative sign. Okay. So it's also said that current entering a node or a closed boundary. So what is mean by closed boundary? For example, if you have this, for example, we have a circuit here. This one we consider a what called a super node. A super node. Okay. Beside this one, we have a lot of current networking here. So this one is I1, this one is I2, and this one is I3, and yeah, this one is I4 and I5. So actually all what you call, if you define this as a closed boundary or super node, so it's also the Kirchhoff current law also applied. Okay, but I think for this course we only concentrate on this one lah, only not. Okay, so this is what we have discussed before, like this. Okay, so I1, so right now as you can see we have I1, I3 and I4 is entering. So that's why we have a positive I1, positive I3, and positive I4. While we have I2 going out and I5 is also going out. So that's why we have negative I2 and negative I5. So that's why we have is equal to 0. Okay, so this must be equal to 0. So, and then we rewrite again. So as you can see, the summation of I1 plus I3 and I4 is equal to I2 and I5. So this is the basic concept of the Kirchhoff current law. Okay. So for example, if you have a current source like this, okay, you can see that this is I1 is actually, we have this direction, and I2 is this direction, and I3 is this direction. We can say that all the current that actually in this direction is a positive I1, this direction is a negative I2, and this direction is positive I3. So you can actually to equivalent this one, you can just use a single current source with a value of I1 minus I2 plus I3. Okay, this is actually application for the Kirchhoff current law. Okay, so instead of you drawing 3 elements of current source, you can actually sum up all together to have a single source with a value of depending on the direction of the current. So if the current is up, and then this is down and up, so this one down meaning that it is a negative values. Okay, so let's do some example. So this is quite, will be quite confusing. As you can see, we have a current direction here, and the current is negative. Okay, so right now, the question is find I1, which is this one, I1, I2, and I3. Where is I3? Okay, this is I3. So try first to find I1. So by using KCL, so I1 is here. So meaning that you need to start your analysis at this node, not A. So please write down the KCL equations for node A. Okay, so all the current entering must positive. Current enters the node must be positive. Current out must be negative. So right now, the current that entering is, okay, there is no current entering. So meaning that all the current is negative 1, negative, negative 6, negative I1 equal to 0. So we rewrite this one. So you have negative 1, positive 6, negative I1 equal to 0. So your I1 is 5 ampere. Okay. Okay. I hope you got it. Okay. Then can we move to I2? So for I2 is this one. So meaning that you need to start your analysis at node B. So current entry must be positive, current out must be negative. So the current entering right now is only this current. So -6. And the current out is negative I2 and 2. So it's equal to 0. Okay, so meaning that your I2 is right now, so this one -6, -2. So this is your I2. So I2 is -8 ampere. Okay. And please proceed with the I3. So the I3, so you can either use this node or you can use this node. It's up to you. Okay, because it's up to you. You can use this node to analyze your I3 or you can use not this one. So since this is from the textbook, so we try to solve by using the equation of the KCL at node C. Okay, you can also use this node, no problem. Okay, but since this is from textbook, so we use node C. So node C, current entry must be positive. So 2, and then the other current are going out. So we have negative, -2, negative I3. Okay. So you should get to +2, negative I3. So your I3 is 4 ampere. Okay. So we have complete this example. Very easy and straightforward. Does it have limit for the current number of current? Like this one will be, oh no, there is no limit. It can be any numbers. There is no limit for the current entering a node. Okay, no limit. You can have 10 or 20 current go in and out in a single node. Okay, so you might ask why you have this. For example, you have this current direction here. Okay, sorry. You have this current direction, but the current is negative. And this one, you have current this direction going down, okay, going this direction, but the value is negative. This one current, okay, but positive. So what is mean actually? What the meaning of this?
Supplying or absorbing.
Sorry? What is the meaning of this? -4 and this direction is like this. What is the meaning?
The current is out.
Sorry?
The current is out.
The current is out. Okay. Actually,
Doctor,
this.
it depends.
Sorry. Okay.
It depends. You know, -4 is going out also, no problem. From not this one, this
Oh,
node.
okay.
So it's going out.
It actually not related to the current going out from the node or current entering out from the node. It's actually not related. Okay. What I want to highlight here is actually if you have this kind of direction and values, -4, but this direction is like this. So meaning that if you can actually say this one is actually, okay, I can write down here is actually similar to positive 4 ampere. If I want to have a positive, the direction must be reverse. That is actually what is all about. Okay, same like this. -3 ampere meaning that the direction is actually in reverse. So you should, if you want to have this positive 3 ampere, meaning that the current should be like this. This one also, if you want to have a positive like this, so the direction must be in reverse direction. Same like this also, +2, so meaning that the current is like this. So it's just a reversal of the direction of the current. If you want to remove the negative, okay, so you need to reverse the direction of the current. That is all about. Negative meaning that this direction is actually reverse. So to have positive 4 ampere, you need to just reverse the direction. I hope you understand this one. Okay, so this one is a positive 4 and the direction is like that. Okay, let's try this example by removing all this negative. Okay, so as you can see, this is the same example, but I reverse the direction of the current. And so when I reverse the direction, all the negative will become positive. So if I want to redo back the what we have done, for example, not A. Okay, I want to have I1 and then I execute the not A. So not A KCL. Should I get the same answer? I1 is equal to 5. So let's see. Not A, okay, KCL. So you see, for not 1, not A, so all the current entering is actually 6 ampere. Okay, and all the current that go out is negative. So 1 ampere, sorry. One and negative I1 equal to 0. So this one I got 5, negative I1. So still I got 5. So meaning that it's the same actually. Okay, the direction is just the reversal of the current. Okay, and then if you want to confirm again, so let's proceed with not B. So not B here. Okay, so not B. So I think no problem this one. No B. Okay, not C. Okay, not C. So this one should be this direction. So this one positive. Not C. Okay, so all the current entering. So you have 2 plus 2. So these 2 plus these 2. Okay, and then the current out is I3. So negative I3. So you have same answer, 4 ampere. Okay, so that is what I want to highlight. Okay, if you want to remove the negative, is you need to reverse the direction of the current. So we finished on the KCL. So very KCL concept is very simple. The summation of current entering the node must equal to 0. Okay. Okay, right now we go for the KVL. So the KVL state that the summation of all the voltage inside a closed loop circuit must equal to 0. Okay, for example, like this circuit, we have a voltage source and then we have resistor that absorb the voltage. Okay, so we can start, usually I start from clockwise. Okay, clockwise. So I start here, the current is moved like this. So I start, so I actually meet the negative part of the voltage source. Okay, so I write my KVL. So my KVL equation. So negative V, and then again, so I meet positive of V1. And then again, I meet positive V2. So as you can see, by using this one, I can my KVL is negative V plus V1 plus V2 equal to 0. And you should note that for the voltage drop across the resistor is I multiplied with the value of the resistor, and V2 is IR2. Okay, so since R1 and R2 are in series, so the current is actually the same. Okay. So the voltage, the current, okay, because the resistor is actually absorbing the energy. So always the polarity, the current will entering the positive polarity of the resistor. Okay, so that's why, as you can see, you use a passive sign convention. So all is actually have a positive sign, meaning that this element is actually absorbing the energy. Okay, and this one also, if you have a voltage source connected in series, okay, you can sum up all this one together to have a single source. So it depends on the polarity. So as you can see, you have this one positive, but the one is a negative. So you can you can actually what you call simplify this circuit by having only a single source by using this formula V1 plus V2 negative V3 because of this polarity. Okay. So if you have a polarity like this, all are actually a positive. Okay. So you just sum up. So meaning that you have a single source, which is V1 plus V2 plus V3. Okay. Okay. This one is the question, but I think we go example. Okay. For example, A here. What is the value of the VAB here? Okay. What is the value of your VAB? The voltage that seen from this terminal. So the voltage seen from this terminal. So like I said, I start with a clockwise. Okay, clockwise. So I meet.
Positive 2.
Is it? Let's say. Let's look. Okay. So this one negative, and then negative, and then positive. So I write my KVL like this.
Sorry, 1, I think. Sorry.
So -1, -3, +5, and then plus VAB, because after this I meet positive VAB, right? So equal to 0. So this one 5 minus 4, okay? Minus 4. So that's why we have VAB, and then we rewrite. So VAB is actually -1 volt. So this one is actually VAB is -1 volt. So you can write down the single source like this. VAB is -1 volt, meaning that this your VAB, okay, we look at the value of this source as a -1 with this polarity. You can also draw your circuit like this. If you want to remove the negative sign here, what you need to do is to reverse the polarity of the voltage source like this. So, okay, so your VAB still will look at same values, which is -1. Okay. As you can see, if you use your KVL, okay, for example, this circuit, KVL, you start from here. Okay, you start from here, you will see negative first. So negative, okay, -1 volt. Okay, you put negative, you see the negative terminal, okay, negative, and then the value of the voltage source is -1 volt. So that's why negative 1 volt plus VAB equal to 0. So you will finally get VAB is equal to -1. If I redraw this one, I reverse the polarity, okay, and because I want to remove this negative value here, so let's see what is the value seen from the VAB. Okay, so start from here also, I will see positive polarity. So positive polarity. What is the value of the voltage source? Positive 1 volt. So positive 1 volt plus VAB, right? Because after this, I see positive polarity. So equal to 0. Same, I will get VAB is negative 1 volt. So it's actually the same with the current direction. So if you want to remove the negative value of the value, so you need to just reverse the polarity. So if the current, you need to remove the direction, and for the voltage source, you need to reverse the polarity. Okay, so I hope you understand. This one is a very important part before we move to the more complicated analysis after this. Okay. So this video is recorded. I think that is the advantage of online what I call teaching and learning, because you can watch it again and again until you understand. Okay. So we have this example. Calculate, this one is quite tricky. Calculate value of the voltage drop across the resistor V1 and the voltage drop of V2 that drop across the resistor 3. Okay. Please bear in mind that the current must entering positive terminal of a resistor. Okay. So for this analysis, what you need to do is to ignore the polarity first. Okay. This is just a trick. You can ignore the polarity first. So just assume that because we know that all the current must entering positive terminal of the resistor. Okay. There is no way that the current entering negative terminal. So you just ignore the what you call defined polarity. So you just use the polarity. So this one positive, this one also must be positive. Ignore first. So what you need to do is actually to find the current, because to get V1, you need to calculate I multiply with R1, and this is also V2 is I multiply with 3 ohm, right? Okay, so the first step is to get the current. Okay, so you can get the current by actually sum all these resistors, because this resistor are okay series. So 5, so this one 20 volt. So the I total is 20 volt over 5. So you should get 4 ampere. Okay. So right now the current is 4 ampere. Then you can write down your V1, 4 multiplied with 2 is 8 volts, right? And for V2 is 4 multiplied with 3 ohm is 12 volts. Okay? And as you can see, by using KVL, the voltage source must equal to V1 plus V2. So right now your voltage source is 20 volt and your V1 is 8 and your V2 is 12. So 8 plus 12 is 20. So same. So that's why this KVL, the summation of the voltage inside a loop, closed loop, must equal to 0. Okay. So meaning that all the voltage source must be absorbed, must equal to the voltage drop across the resistor in a circuit. Okay. So right now your the voltage drop across V1 is across this resistor is 4 ohm. Sorry, 4 ohm is it? 8, sorry. 8 volt, right? And this one is
12.
12. Okay. After you got this one, then you need to answer V1 and V2. So your V1 polarity is this one, positive, negative. So meaning that if you put your voltmeter, this one positive, and this one is negative, okay, your voltmeter will give you the reading of 8 volt, right? And for this one, V2, if you put your terminal, your probe, positive probe, and this one is negative probe, you should get the reading is positive 12, right? Okay. What is the reading when I change the probe? This one is negative, this one is positive. Negative meaning that this one is the black cable, the common cable. Okay, what is the reading?
Doctor, I think it will be the same because the total should be the same 20 volts, so the sum should be 0.
Yeah, the value is the same, but the polarity is negative.
Negative.
Yes, that is what is the meaning of like this. It's actually how you actually put your. It's actually how you actually put your meter. Okay, so this is a tricky question. So my suggestion is actually what you need to do is just use the circuit by ignoring all the voltage polarity, because this polarity is actually just after you have calculated all the values, then you can actually go back to what is the polarity. It's actually, how to say, this is actually referring to actually the how you connect the reading, the equipment that you want to measure the voltage. Okay, because this one, if you put the current must go inside positive of the resistor. Okay, if the reading is actually, if you put this one positive and this one negative, you will have a 8 volt. This one also, if you put your positive probe and negative like this, so you will have a same answer, positive 12. But if you swap this one going here and this probe is going here, so then you have negative 12 volt. Okay, so negative meaning that your polarity, your common point is, your common probe is you put here, and the negative probe is you put here. So that is. So I hope you understand this one. Okay. Okay. So this is exercise. So I leave it to you to do it. So I give you about maybe 5 minutes. Okay, the answer is here. So you try first. Okay. Try first and then we will discuss. So find the current I, which is shown here. Sorry. Okay, and the power absorbed by each element. So you can actually solve this by using the KCL, the KVL, or Ohm's law. Okay, Alhamdulillah. So let's discuss this solution. Okay, for the current. Okay, so the current. So here you see that we have 3 branch. Okay, the current. So this one is 1 node. So you need to use your KCL at this node. So the current direction for this one is actually going down here because the current source is going down 10 ampere. So by using the KCL at node 1, so this is one node 1. So all the current that entering must be positive. So 4 amperes and the current out must be negative. So negative I and then negative 10. So this one 0. So your I, negative I, this one negative 6, 0. So meaning that your I is negative 6 ampere. Okay, so shown here, the answer 6 amperes. So meaning that your current is actually negative 6 ampere with this direction. Okay. 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 So next is to find the power absorbed by these each elements. So let's start with the current source first. Okay. So by using the passive sign convention, the current that going into positive terminal, so it must have a positive sign. But if the current is entering the negative terminal of the element, the power must be negative. So as you can see here, the current is this direction and is actually entering negative terminal. So meaning that the power of this one is actually P is equal to negative, and the value of the voltage is 15 and the value of the current is 10. So this is why we have negative 150 watt. Okay, this one. And let's look at this element. So the current direction is 4 ampere, meaning that it is, as you can see, is entering the positive terminal of the element. So your power is positive. The value of the voltage is 15 and the current is 4 ampere. So you should get positive 60 watt. Okay. And this element. Okay. So this element, the current with this direction, okay, is entering negative terminal. So you should put negative. The voltage value is 9 volts. The current value is negative 6 ampere. Okay, so negative, negative, so positive 54 watt. And this element, okay, so the power, the current, because this element are in series with the 6 volt, so the same current will flow inside 6 volt. Okay, and the current, as you can see, is entering the negative terminal. So negative, the voltage value is 6 volts. The current value is negative 6 ampere. So this one negative, negative, meaning that 36 watt. Okay, so as you can see here, only current source is actually supplying the power through inside the circuit, while the other source is actually absorbing the power. Okay, so this actually follows the power convention, the conservation of power, where the summation of power inside a circuit must be equal to 0. So if you can see, negative 650 watt plus 60 plus 54 plus 36. If you equate this, you should get 0. Okay. Okay, I think I hope you understand this one, especially on the sign and okay, the sign, the power convention, and so on. Okay, we have a large class here. So I think the registered is around 40 something, 47. So I don't know how many of us right now. It's not easy to see everyone here, because when I share the screen, so I cannot see the number of participants. So that's why some lecturers, they are using multiple screen. Sometimes my friend use 3 screens, okay? 3 screen, vertical and horizontal, just to engage the students. Okay, so right now I'm just using a single screen, but I'm planning to buy another screen, second-hand screen. So itulah, budget tak ada, budget is very limited, so I just can't afford the second, what they call the second-hand screen. But the second-hand screen right now is still the quality is quite good also, because I'm actually using a second-hand desktop, okay, that I bought from overseas, which is very good. This one is it's actually a CPU used for server in United States, but it's still running quite good, very fast. Okay. Okay, this is the last exercise. Okay, so this is quite challenging compared to the previous exercise. So I want to do this in different style. Okay. So short sharing first. Okay, so right now I can see how many of us assuming. Oh, sorry. I just see the chat right now. How to see the participant? Oh, 41. Okay, good. Okay, let's share my screen right now. Okay. Okay, I'm using what we call the Microsoft Whiteboard. So it's much easier to conteng here, to draw and so on. Okay. And also I want to introduce you with the use of what we call the online calculator. So it's easy for me to show you, because this one is require what we call the simultaneous equation solution. Okay, so if you using calculator, it's much easier. So I can show you the how to use the calculator. Okay, I hope you have your calculator right now with you, because we're using this calculator. Oops, sorry, this one big screen. Okay, so I hope you can see both the screen and my whiteboard and also my calculator. Okay, so find the current and voltage in the circuit shown below. This one I need to background. Sorry. Oh, sorry. How to, this one is actually, okay. Find the current and voltage in the circuit shown here. Maybe you need to, it's actually come from your textbook, practice problem 2.8. So using the KCL and KVL and also your Ohms, basic Ohms law. So find the V1, the voltage drop, V1, V2, V3, and also the current I1, the branch current I1, I2, and also I3. Okay, let's start the discussion of the solution. Okay, find the current and the voltage. Okay, so how to start? That is the main problem. Okay, where and how to start the analysis with this circuit. Okay, so I can see from here what we can start is actually we can use we have two loops here. Oh, sorry, this one very big. Okay, two loops. Okay, and then we have a knot here. Okay, and then we have three variables: V1, V2, V3, and also I1, I2, I3. So with three variables, we need three equations. Okay, so I think from here we can have all the three equations. So the first one is from the first loop. Okay, so the first loop is actually the KVL. Okay, the KVL for the first loop. So we start from here. So what you see is -10, positive V1, and positive V2. Okay, so -10 plus V1 plus V2, and then this is equal to 0. And then another one is actually this one. Okay, just ignore. Okay, firstly, as I said, you just ignore the polarity. So you said, because we know that the current will always entering positive terminal of the resistor. Okay, so same like this. Okay, as you can see, if I use this one, I will see that this one is a negative. Okay, so just what you call oh, tak boleh lah this one. This one, okay, because this is already defined. Okay, already defined. So we just follow the polarity. Okay, just follow. So let's say -10 plus V1 plus V2. This one is the first equations. And from the second equation like this, so we see negative first. So we just follow negative V2 plus V3 -6. This one equal to 0. So you will have your negative V2 plus V3 equal to 6. Okay, this one is your equation 2. Okay, and then I have the third equation come from this branch. So you have I1 plus I1 is equals to I1 minus I2 minus I3 equal to 0. So this is the third equations. But we know that V1 is two I1, V2 is 8 I2, and V3 is 4 I3. Okay, so right now we have three equations. You have this one, V1, V2, and so on. Okay, but you can change this one equation into I1, I2, and I3. So let's say that your V1 is 2I1 plus V2 is your 8I2 plus 0I3. So this one is equal to 10. Okay. So this is your equation. And from the second equation, okay, so I1 is actually from V2 is 0. So this one 0 plus so this one is negative. Okay. Negative 8I2 plus V3 is 4I3. So this one is 6. And then the last one is I1 minus I2 minus I3 is equal to 0. This one is equation 6. So as you can see, we have 3 equations and 3 variables, I1, I2, and I3. So you can use your calculator to solve this by using simultaneous equation method from the calculator. So I hope you have already know how to use the calculator. But if you don't know how to use the calculator to solve the simultaneous equation, so I can show you in the screen. So right now I have my online calculator here. Okay, what you need to do, just firstly must you turn on the calculator. I think this one show here is actually a universal calculator. Okay, but for UTM student, it is advisable to use the what they call the Casio FX. I guess. Okay, mode 5.2. Oh, yeah, it depends on the model. So if the
Yeah, this
newer,
for the test user.
sorry. Okay, so if you use the modern calculator, okay, I don't have the model here. Just use type mode, okay, mode, and then use until you see this the display here, equation. Click equation, the mode number 1. Okay, and here it will ask you how many unknowns, how many variables. So in this case, we have 3 unknowns. So just click 3 unknowns. So you just type your A1. So your A1 right now is 2. Okay. And your element number 2 is B1, which is 8, the constant. And then your element number, the third one is 0. Okay. 0I3, 0. Just put the constant there. And then D1 is your is actually the value here equals to 10. And then it is repeated to the second equations. So your first element for the second equation is 0. The second element is negative 8. The third element is 4. Sorry. Sorry, I think this one, yeah, I made error. Hold on. I need to go back. So A1, A2, A3. Hey, why? Hold on. A1 is 2. Okay. Okay, B1. Okay, good. Okay, C1. Okay, 0. Okay. 10, 0, 4. Okay. And then the 6. And then the third equation is, this one is 1. B3 is negative 1. And C3 is also negative 1. And then D3 is 0. Okay. So X is referring to the first element. So I1 is 3. Okay. Your Y element, which is referring to I2, is 0 0.5, okay, and your Z is referring to the element number 3, which is I3. So your Z, which is I3, is 2.5. So this is your current values. Okay, which is, if you refer back to the answer, so it is correct. So I1 is 3 amperes, the I2 is 500 milliampere or 0.5, and I3 is 2.5. Okay, so it depends on your calculator. Some calculator, that the older one, you need to repeatedly push mode 25, right? Try and error. But for the modern equation, modern calculator, you just simply go to this mode and then just choose equation 1 and then choose what is the equation variables. Okay, rather if you have a 3 simultaneous equation, just click 3, or if you have 2 simultaneous equation, type 2. Okay, and then if you want to go back, just if you want to go back to the normal mode, just mode and then just type common, I think computer. Okay, and then it will restart back to the common calculator. Okay, so from that you got the current I1, I2, I3. So from here you can calculate directly your V1. So your V1 is 2 multiplied with I1. So you have 6 volts. V2 is 8 multiplied with 0.5. So you should get 4 volts. And your V3 is 4 multiplied with I3, which is 2.5. So this one should get 10 volts. Okay. Okay, I think that's all from me for today. And for tomorrow class, as I said before, there will be no what you call online class, but I will give you the video that you need to watch. So the video will be on the series resistor and the voltage division. Okay, so the notes also, the notes for week 2 also I will give you inside the WhatsApp group lah. Okay, for this time I give you into WhatsApp group, so you just look at that. And also I will prepare some exercise in the video, so you need to just do it. Okay, because this subject is required students what I call exercise. Okay, students have exercise to make sure that they understand the concept and so on. It's like a mathematics. So mathematics, so you need to do a lot of homeworks, need to do a lot of exercise. Okay, to familiarize the problems and so on. So I think that's all from me. Thank you very much for your attendance for this class. So we meet again insyaAllah next time. Okay. Ya, Assalamualaikum.
Thank you, Doctor.